Right, that is awesome. Determine the value of the current measured by the ammeter. Right, so what we need to understand is that if we have 5 amps at this point, it means when we get to this point, current is going to split. If you get here to this point, right, current will split. That's why we have I1 and I2, so it's going to be shared. The 0.5 is going to be shared among those two resistors, and then once we get to this point, they'll sum up again. I1 and I2 will sum up to 0.5. So at the end of the day, the ammeter reading will still give us 0.50 amps. Okay, what's next? Question wants us to calculate the potential difference across the 6 ohm resistor. Right, so in this case we are using Ohm's law, right? V equals I times R, right? I being the current in through that resistor, so this is equal to 0.50 multiplied by 6.0. right, this will give us 3 volts. Awesome. Right, this must be simple. 3 volts there. Now the question also wants us to show that the potential difference across the 20 ohm resistor is 9 volts. Right, so what we need to understand is that if we have a power supply of 12 volts, so considering the issue of the conservation of energy, what it means is that if we have 3 volts across this one, we have 3 volts there. The other, or the remainder of the potential difference being supplied, will be across these two, because they are connected at one point. So when resistors are connected in parallel, it means they share the same potential difference. Okay, so what it means is that this whole part will have 9 volts. Okay, how do we get that? It's just a matter of subtracting. So we're coming down here, we're saying, right, the potential difference across that PD across the 20 ohm resistor equals 12 volts minus 3 volts, and this will give us 9 volts. Okay, now the question wants us to calculate the resistance of R. The resistance of R. So how do we get the resistance of R? We need to go back. Now the fact that we know that now know that the voltage across those two resistors is 9 volts, we can actually calculate I1 and I2. So we'll start by calculating I2. Right, we are using Ohm's law. All right, so let's come down here. Right, we're saying using Ohm's law, V is equal to IR. So that means we're having 9 volts being equal to I2 times 20 ohms, which means that I2 will be equal to 9 over 20. Right, so if you calculate that, what do we get? I2 is equal to 9 divided by 20. Right, I'm getting 0.45. This means that I1 is equal to 0.50, which is the current coming through that branch, minus 0.45. So if you subtract that, what do we get? We'll get 0.05 amps. Remember the voltage across that whole part with parallel resistors, so it means resistor R also has 9 volts. So what it means, you're also using Ohm's law, V equal I times R. So that means your R is equal to V over I. the potential difference across that is 9 volts, and then we're dividing this by 0.05, right? So this is 9 divided by 0.05. I'm getting 180 ohms. So that is the value of the resistor there.